Hello everyone, thanks for coming. So today we're going to do a short review of our week 1 lecture in our Calculus 3 class. So in this week, we introduce the coordinate system and the vectors. So for 2D plane, the set of all points A and B denoted by R square forms the 2D coordinate system. In 3D space, the set of all points A, B, C denoted by R cubic forms the 3D coordinate system. So generally speaking, for Rn, the set of all points AI1 to An, where Ai is a real number, forms the Rn coordinate system. So the coordinate system can help us locate the position of a point in the space. Then we introduce the concept of vectors. So representation, since we are mainly focused on 2D and 3D space, so the representation, I only list 2D and 3D representation here. So sharp bracket AB or sharp bracket ABC, which means that the vector starts from the origin and ends at AB for 2D case and AB or ABC for the 3D case. So there are two factors that shapes the vector. The magnitude, which is also called the length, for 2D case is square root of a squared plus b squared. For 3D case is the square root of a squared plus b squared plus c squared. Also, we have the direction in order to describe the vector. So here are some basic algebra for vectors. We have the scalar multiplication alpha a. So the new vector alpha a has exactly the same or the opposite direction as the original vector a, while its length is the length of a multiplied by the length of the absolute value of alpha. The addition for vector is associative. Also, we have the additive identity 0, which means that the vector is of length 0. Also, for v, there exists minus v such that v plus minus v is 0. Addition is commutative, and the scalar multiply also associatively. There is also the distribution rule for multiplication, no matter for the scalar multiplication or vector addition. Over scalar or vector addition, alpha plus b equals to alpha v plus bv, and alpha times v plus w equals to alpha v plus alpha w. There is the scalar multiplication identity 1, which means 1 times v equals to v, 0 times v equals to 0. Finally, we have the standard basis function for R cubic. The standard basis functions are denoted by I, which is the unit vector along the x-axis, J, which is a unit vector along the y-axis, and k, which is a unit vector along the z-axis. So any vector can be written uniquely as a sum of scalar multiples I, j, and k, and please think about how to give a proof to this statement. So basically, from the general representation, we just need to find the three factors such that adding vector v can be decomposed as v equals to ai plus bj plus ck. We just need to find this a, j, a, b, and c, which is quite straightforward from the sharp bracket representation of any vector. Thanks for listening.